All right, let's go back to Friday. We ended with this slide. We'll begin with this slide. The remainder theorem says this. If a polynomial f of x is divided by x minus c, let's go like this. Instead of saying divided by x minus c, let's say divided by x minus 4. Okay? The remainder equals f of c. So whatever the remainder is, that goes here. Okay, so what's going to go in here? F of 4. You got it. Good job. Really, think of it as the 0. What's the 0 out of this divisor? 4. And that's what they're telling you. Okay, that's what the remainder theorem says. Use the polynomial division to find f of negative 2. Well, if you think about it, guys, this is kind of what they're saying. F of negative 2, if you're told to evaluate the function at negative 2, the answer will be what? The remainder. So last week you and I did this right here, and we said if we use synthetic division, I'm going to draw another arrow over here. This is the same as dividing by x plus 2. Got it. Okay, just so you know that. All right, so what do we put out here? Negative 2. Okay, and then the 1, a negative 1, a negative 2, and a negative 3. That's the remainder. Synthetics says put a 0 in the corner, add straight down, you get 1. This is what when you multiply? Add down. Multiply. Add down. Multiply. Negative 2, add down. Multiply. 8. Remainder. 5. Is that where you quit on the quiz? In 2 days, you'll quiz. You can have this problem. Are you going to quit right there? No, because it says evaluate the function at negative 2. So what you have to say now is f, try that again. F, my function at negative 2 is what? 5. Okay, there it is. So if you quit right there, I'll give you half credit. And that's being nice, because that's really not the answer. This, you have to understand, if you leave this, and some people will even do this. Some people will say the answer is x cubed minus x squared plus x minus 4. And they might even go like this. 5 divided by x plus 2. They might write that as their answer. That is the answer if I was what? If I was actually what? Dividing by x plus 2, that is the answer. But that's not what this problem said. This problem said evaluate the function at negative 2. And the remainder theorem says treat it as though you're dividing. Just put the negative 2 right there. This becomes your answer. And this is the remainder. Okay? Good? Okay. It's kind of weird if you ask me because f of negative 2, you put the negative 2 there. But if I tell you take your function and divide by x plus 2, what do you put out here? It's the opposite, or the 0 comes out here. So you got to know, am I dividing or am I just evaluating? Okay, this is a big repeat of Friday. I did this on Friday, so hopefully you're okay. Anybody have questions? No. Okay, next slide. The factor theorem. And really this is all you're learning because I did everything up to this. It says a polynomial f of x has a factor of what? X minus k. Let's say x minus 5. Only if f of what? 5 equals what? 0. Okay, so what they're saying to you is this. If 5 is a what? If 5 is a 0, comma, then we know there's a factor. And what's the factor? If 5 is a 0, it's going to be x minus 5. That's what they're saying. If I told you 7 gives you 0, by the way, this is a 0, this is an x-intercept, this is a solution. If I told you 7 is a solution, 7 is an x-intercept, 7 is a 0, that also means you have a what?
Factor.
What's the factor?
X minus 7.
X minus 7. What if I said negative 3 is an x-intercept? X plus 3 is a factor, okay? Notice how I'm changing the words on you. 7 is a 0. Oh, x minus 7 is a factor. Negative 3 is an x-intercept. Same thing. X plus 3 is a factor. All right, this is it. This is the problem we're trying. Use synthetic division to determine if this is a what? Is a factor. Is x minus 3 truly a factor of this? To be a factor, guys, what do you know? The remainder is 0. Exactly. Like, hey, guys, is 4 a factor of 12?
Yes.
How many times does it go in there? 3 with a remainder of 0. To be a factor, the remainder is 0. Is x minus 3 a factor of this? Do your division right now. See what you get. If you're checking to see if x minus 3 is a factor, really what you're doing is dividing. So what's going on in front? Always put what out here? The 0, so it's got to be what? 3. Okay, and then you put what in the corner? 0. Add down 1, multiply, you get what? 3. Down. Multiply. Add down. Multiply. Answer. 0. But the true answer is, that is your remainder. The true answer is this a factor of this? Yes or no?
Yes.
Okay, the answer is yes. Okay, so I'll go down. So I'll say x minus 3 is a what?
Factor.
Factor because right there, you have a remainder of 0.
Don't you just plug it in?
I could, but they said use synthetic what?
Division.
So yes, you can. You can plug it in, and you're supposed to get what?
0.
0.
Check your answer.
Yep. All right. Okay. Use synthetic. They're telling you to use it, so you got to use it to confirm that x equals 3 is a 0 of this function. Okay, just do that. Is it a 0? Really, that's what they're saying. Is f of 3 truly a 0? Okay, here it comes. The coefficients are, say it.
1, 4, 1, 6.
And if you want to know if 3 is a 0, f of 3, you put what here? You put the 3 there. You're not dividing, you're just evaluating. Bring down the 0, or bring down the 1. Multiply. Multiply. Here you get -2. Multiply. So, is it a 0? Yes. So, yes, it is. Okay? All right, next. Then, use the result to write a complete factorization of the polynomial. Okay, so here's the deal. If this is a 0, which it is, this is a 0, but when it's a 0, it creates a factor. What's the factor? X minus 3 times, right? Okay, so when you did this, this is exactly as though you're dividing by what? X minus 3. So that's why I put the x minus 3 there, but what's left? This is the quotient, right? This is the answer to division. So what's left is 1, negative 1, negative 2, which
minus 2.
gives us, right, there it is. So you got a factor, x minus 3, times your quotient, but your quotient is the other factor. Because it's your divisor times your answer to get your polynomial. All right, completely factor this. You guys, we're almost done. X minus 3 times
X minus 2.
X minus 2.
X plus
times
X
plus
plus
1.
1.
plus 1. There you go. So this is you saying, okay, yes, it's a 0. If it's a 0, it's a factor. Write it as though it's a factor. And it's also you thinking, well, it's this factor times what's ever left, and what's ever left can be factored again. Jameson?
That's what it is. I didn't see where you got the x squared minus x. That was John.
Yeah, it's right here. 1. This is the answer to division. You got that? Okay. This is the answer to division. It's your divisor times your answer to check your work. Well, when you write it like that times that, this still can be factored into this. So, does everybody understand that this right here, if you factor it, is this?
Yeah.
Okay, and we did it just by simply dividing. We divided x minus 3. That's what this is, right? I wrote it somewhere, didn't I? Yeah, right here. It's as though you're dividing by that when you put that. Okay. No questions? This is what you're doing today. You don't have questions? All right, last one, then we're done. Okay. Use synthetic substitution again to help write this polynomial function in what form? They want you to factor this with two of the factors given. Well, look, they've already given you this times this times what? Well, you guys, if this is a factor, what 0 comes out of this one? 1. The 0 is 1. What's the 0 out of this one? Negative 1. So if that's what you've been given, then take synthetic and help yourself out. Coefficients are 1,
0.
0.
Negative 5.
Okay, and let's just start here. If that's the 0, let's put the 1 out here and just work it out. 0. Multiply. How do I know the answer is 0 for sure? Because it's a factor. They told me, here are 2 factors of your polynomial. I better get 0, right? So right now, here's what I have. I have x minus 1 times this polynomial. But wait a minute.
Factor out x plus
I know there's another factor, x plus 1. So couldn't I do this whole synthetic thing again?
Yeah.
Okay, with what 0 though?
Negative 1.
Negative 1 this time, right? Because that came from this one. So do it again. Start over. Add, multiply, add, multiply. You better get what?
0.
You better get 0 because it is a factor. Negative 1. There, I get negative 1. Add down 0. There, 0. Add down negative 4. 4. Oh, I lined that up fairly bad. Okay, hang on. Try that again. Okay. All right, sorry. There you go. Yes, that's it. 0, got it. Okay, so this should be a 0, which means it's a factor, times a factor, times.
You did it wrong.
Because you were using the answers from the top as your things to multiply.
Yeah, it's supposed to be a 0 and not a 1.
It's supposed to be 1, 0, negative 5, 0, 4 on the top.
No, you did it right.
Well, I don't know what you're saying.
You did it
Are
right.
you saying I'm supposed to go back up here?
No, it's right.
No, no, no.
You did
And
it
first,
right.
okay, we need to have zeros
Just keep
instead of
going.
that 1. It should go 1,
It should go 1,
0,
0,
negative 5, 0, 4. You used your answer.
That's what you're supposed
That's what I'm
You're
doing. Right, right.
supposed to.
Okay, watch. Okay, watch this. If I give you 100, and I tell you one of your factors is 2, and another one is 5. There's your two factors. If you divide this by 2, you get 50, with a remainder of 0, right? Okay, but I tell you this is another factor. Well, don't go to 100, go to 50. Divide that by what? 5. Now the answer is, that's what's left, right? 25 is the answer. Then I'll try factor this again. 5 times what? 5. So what I'm trying to tell you is, I don't have to go back up to the original.
Like 50 divided by 5.
That's
It's 10, yes, 10. It's 10, sorry. Okay,
But that doesn't everything. Wait.
2 times 5.
Oh.
Okay, anyways, what I'm trying to say is work your way down. So guys, once you get to here, 1, 1, negative 4, just stay with those numbers. And if this is truly a factor, it should still go into what's left. Then I did it, I got 0. Are you with me now? Okay, now this is good because you're supposed to get 0. This is what's left. These 3 numbers go into that blank, which is what, Jake?
That's not my question.
Oh.
They will let her.
Okay, x squared minus 4. There you go.
Yeah.
Okay, what's your question?
So let's say like 100 is a factor of 100,
Okay.
but 100 isn't a factor of 50.
Yeah.
He's just breaking down.
You know what they're doing? They're giving you 2 factors of your polynomial, and I'm just going slowly. X minus 1 goes in there this many times. Then I do x plus 1 goes into here
Oh, okay.
this many times. This is what's left.
Yeah.
What's left is here. Now guys, can you factor that?
X plus 2x minus 2.
Yeah, it's a difference of 2 squares. You should be able to factor that pretty quick. X minus 1 times x plus 1 times x plus 2 times x minus 2. Is this completely factored?
Yeah.
And you should know it is because every factor is linear. Once you get to x to the first, there's no more factor. You can't factor linear factors, okay? Go ahead.
How
Oh,
was x squared minus 4?
is it x squared minus 1? Okay, here's your remainder.
Well, wouldn't it be,
This is your,
miss 0?
yeah, but this is your constant term, negative 4. This is the number in front of x. So that's 0x. And then this is the number in front of what?
Wouldn't it be x?
No, I know. Okay, I know what you're thinking. This is the constant. This is the remainder. This is the constant. Then the x term. Then the x squared. If I had another number, it would be the x cubed.
I have 5 numbers.
That's because you went back up here at the
No, I
beginning.
went to the answer.
You went to
You
the,
sent the remainder in it? No.
I'll come and look, Grace. I'll come and look. Hey guys, you just have to do it like this. You just take the coefficients of the original, right here. Okay? You know that's a factor, so this is a 0 that you'll put in. You'll divide it out, and you'll get this, right? Okay, now you don't have to go back to the original because this is what's left. It's x minus 1 times this. Well, x plus 1 should go into this also. Do it again, you get 0. This is what's left, and that's what I stuck in there, right here. Then I factor that. And it almost always quadratic in the end. Do you need to try one in your book?
No.
Did we try one?
No, we're good. No, this is deeper.
All right. Go. Just go to work. Now you don't have anything else. Just go to work. Yeah.
Could you like reverse it? Could you put -1 first?
Yes. Yes. Yes.
Okay.
Guys, you can put negative. You can do -1 first, +1 second, because they're both factors. It doesn't matter which order you go. Is there anybody out there that would like me to do this? 47 or 48 were kind of confusing. Would you like that on the board? Okay.
I wasn't here for it.
I want to do it.
Jake.
Doesn't sound like you guys want to see it.
Honestly, yeah, but too much time.